Hi, I want to show you a problem that has to do with energy that you might need to use sometime. And so, what I'm going to show you here is a problem about a rock that's on the bottom of a hill. Or this could be a car, but in this case, it's a rock. Or it could be a bike, but it's a rock. All right. And this rock happens to have a mass of 2 kilograms. But it also has an energy because it's rolling. It has a kinetic energy of 400 joules. Just happens to have 400 joules of kinetic energy. We already know that. Okay. And so I'm trying to solve a problem here. What I want to know is how high it gets up the hill. I want to know the height. So I'm going to write that there too. So I've written down the things that are important to me. Now, if I'm talking about how high it gets up the hill, I must be talking about gravitational potential energy. Gravitational potential energy has to do with how high you are. So I'm going to write potential energy. Gravitational potential energy equals mass times gravity times height. Now, how am I going to think about that? Like, do I know the gravitational potential energy? Well, here's the thing. I do know gravitational potential energy because I know the kinetic energy at the beginning. At the beginning, the pi of kinetic energy is filled with 400 joules of kinetic energy. And at the end, the rock is going to roll up the hill and it's going to stop somewhere on the hill. All right. It might roll back down, but it's only going to get so high before it stops. Okay. And so that means it won't have any kinetic energy then. Well, we can't lose or gain energy. So when the rock rolls up the hill, it will stop. And therefore, at the end, it will all be potential energy, gravitational potential energy. This 400 joules at the start is going to be 400 joules at the end. Okay. So I'm going to write that in my equation now that the potential energy is 400 joules at the end when it gets up the hill. And I know that that potential energy is equal to the mass, which is 2 kilograms, times the gravity, which we know, and you guys wrote down in your notebook on Earth is 10 meters per second every second, times the height. Now, you might say, Mr. Langer, I don't know how to do that problem. Yes, you do. Okay. This is a simple math problem. I'm just going to go down here and show you that you've done this about a million times in algebra class. 400 equals 2 times 10 times the height. Or actually, in math class, it probably said x here. But it doesn't matter if it's x. It could be a height. Could be an h. Okay. So how do you solve this problem? Well, you would just take 400 equals 10 times x because you multiplied 2 times 10. Then you divide, oops, I'm sorry, it would be 20 times x. 2 times 10 is 20. Okay. Then you divide by both sides by 20. And that would mean that 400 divided by 20 is 20. So 20 equals x. So I've solved for x, right? But this is the same equation. 400 equals 2 times 10 times height instead of 400 equals 2 times 10 times x. So this is going to be 20 equals the height. Now you've got to think height. What kind of units are on height? I need to tell people how I measured this. Well, we know that we've been measuring things in meters. It says right in here that we're using meters. Okay. So you're going to have to write here that the height is going to be in meters. So this rock will be able to go 20 meters up the hill, and that's where it's going to stop, okay? Because all its kinetic energy will be gone and change to potential energy, okay? And so that's how you solve through that problem. Watch the video again if you need some help.